All right. So once again, this is section 5.2 still. This is example 6, and there's 1, 2, 3, 4, 5 examples under the example 6 tab that we'll be going over. Right, so if we look at A, this shouldn't be that bad at this point, guys. It says write each expression in simplest form, and then we're going to assume all variables are positive. So when we went back to example 5, and we had to write, let me find one, the absolute value, we don't have to do that this time because in these examples, the directions are saying that we can assume all variables are positive. Okay, so kind of same scenario as in example 5. I'm going to go and I'm going to separate this. So 5th root of 4 times the 5th root of a to the 8th times the 5th root of b to the 14th times the 5th root of c to the 5th. Okay, now the 5th root of 4, that doesn't simplify. Okay, times, well, this is just a times the 5th root of, there's 3 left, a cubed. This is b squared, so it would take 10 of those, 5th root of b to the 4th, times, well, c and c, or 5 and 5, it just leaves a c. Okay, so if I put these all together, I have a on the outside, I have a b squared on the outside, and I have a c on the outside, and then I have 5th root of 4a cubed b to the 4th. All right, let's look at b. Okay, so the problem with this, well, first of all, we'll do this first. Let's simplify the bottom first. So this is just y squared cubed root of y squared. Okay, now, the problem with this is that we have a radical in the denominator. Okay, so we have to get it out. So like we did before, the easiest way to get this out, if this is cubed root, let's make this y to the 3rd power. Okay, so in order to do that, we want to multiply it by the cubed root of y. But we do that to the bottom, we have to do that to the top as well. Okay, so the top would get x times cubed root of y over y squared times cubed root of, well, y squared times y, which is y to the 3rd. Okay, well, cubed root of y to the 3rd, guys, that's just y. So top is x cubed root of y over y squared times y is y to the 3rd. We know all variables are positive, which means y can't be 0. So this will be our final answer. All right, I want you to try to do C on your own. It's very similar to B. So try this one on your own. Pause the video, try it on your own, and then we'll go over it. All right, guys, so if you look at this, when we simplify the bottom at first, we get y to the 4 times cubed root of y. Okay, but we want to get rid of this radical. Okay, so cubed root of y, we want to make it cubed root of y cubed. Okay, so we multiply it by cubed root of y squared. All right, so when we do that to the bottom, we have to do it to the numerator as well. So when we simplify it, we get x squared times cubed root of y squared, and then y to the 4th on bottom times cubed root of y to the 3rd, which is just y, and y to the 4th times y is y to the 5th, and then the top stays the same, so this is our answer. And once again, where it says assume all variables are positive, that means that y cannot equal to 0 because we know it's positive, so we don't have to put that in our stipulations. All right, let's look at D. Now I'm going to go ahead and I'm still going to separate these like I normally do. Okay, so I'm just going to do this as 14 over 2 times x over x to the 3/4 times y to the 1/3 over, well, 1, there's just one y, over, and then we have a z to the -6 on top, so I'm going to put 1 over z to the -6. All right, so 14 over 2, this goes to 7 times, well, x over x to the 3/4, think of this as x to the 1 or x to the 4/4, and then we subtract them. So this will be x to the 1/4. Okay, this is just y to the 1/3. And remember, when there's a negative, we can make it positive by either going from the numerator to the denominator or the denominator to the numerator. So we can move this up top and it'd just be z to the positive 6. Okay, so I put all these together. This is 7x to the 1/4, y to the 1/3, z to the 6th. That's my answer. And it says all variables are positive, so we don't have to worry about these being 0, so we don't need to have any stipulations. All right, let's look at E now. This is the last one for example 6. All right, so I can look at this, and I think this will be easier to do an exponential power. So I'm going to change this to exponential form. So x to the 10/4 over x to the 5/6. Okay, now it's easy to see that this is just going to be x to the 10/4 minus 5/6. Okay, now the hard part is 10/4 minus 5/6, which isn't that hard. Okay, so common denominator is 12, so I'd multiply this by 3. So 30 over 12 minus, this would be multiplied by 2. 10 over 12, which is 20 over 12, which reduces to, each of those going to 4, so 5/3. So this is just x to the 5/3. And that is my answer. If I wanted to write this in radical form, that would also be what? X times cubed root of x squared. Those are the same thing. So either one of those would be acceptable.